Hello, you nines, and welcome to the first video of the week. Once again, I hope you're sitting down and have notes in front of you ready to write. So today we're going to look at factorizing quadratics. And last week we learned how to factorize a quadratic when this here, a, was 1. Today we're going to look at a method that teaches us to split that into a pair of factors when a is not 1. Now, one thing I should point out is that there are lots of different ways to do this. I know each teacher in this school has their own preferred method, and then the textbook has another different method entirely. So by the time you've reached years end of year 9, 10, 11, you'll have seen several different methods how to do this. Today we're going to look at one called the hashtag method. It has another name, but I'm calling it hashtag method because that's cool. Alright, so we have all quadratics forms ax squared plus bx plus c. So let's take this one. X squared plus 7x plus 6. Now I know the coefficient in front is 1. So our old method of sum and product would work. So let's just consider that using sum and product so we know the answer and we know what we're going to end up with. Alright, so we're looking, using sum and product, we'd be looking for things that multiply to 6 and add to 7. That's quite easy, it's 1 and 6. So at the end of this process, we'd like to see this factorized in x plus 1, x plus 6. Now clearly this is quite easy and we do it with sum and product, but I just want to show you the process on an easy one first. Alright, the reason it's called a hashtag is because we draw a grid like this. So can you please draw that grid also? This method has 5 steps, and to start off with, for each step we're going to draw a separate grid. So 1, 2, 3, 4, 5, etc. Normally when you do it, you'll only do all the work on one grid, but this is just to show you each step in turn. Okay, so you notice here we have the numbers, 1 in front, that's A, B, and a C. A, B, C. Then in the top of the grid, you put the numbers there. 1 where A is, 7 where B is, and A dot C, remember in maths, dot quite often means multiply. A dot C is 1 times C, so 1 times 6 is 6. And that is step 1. Step 1 is filling in the top row, A, B, A, C. Moving on to step 2. In step 2, we find 2 numbers, and these 2 numbers must add to B and multiply to C. You should notice a pattern here. That's very similar to what we did in sum and product. So those 2 numbers are factors of AC and they multiply to B. All right? Once you find those 2 numbers, you can put them in where those are, in these green boxes. The good news is it doesn't matter which order you put them in. You can put them 6, 1 or 1, 6. Both methods will work. That's step 2. Step 3, and once again, I hope you're drawing a new grid. Once you have all those numbers from what we drew before, you take the top left and the bottom right corner, and you find the greatest common factor or highest common factor. Now here, the highest common factor is the number that goes into both and is the highest number that goes into both. If we're looking at 1 and 6, clearly the highest common factor will be 1. That's step 3. Now, we multiply everywhere. Think about putting a time sign there, there, and there. 1 times something is 6, so that must be 6. 1 times something is 1, and 1 times something is 1. Essentially, we're trying to make those 3 out of multiplies. And now we've filled in our entire grid, comes the final touch. We draw diagonals across those 4 numbers. A person in my other class called this putting the band-aid on because it looks a little like a band-aid. And then this column here is the coefficient of x column, and this column here is the constant column, or numbers, just ordinary numbers. And that red half of the band-aid symbolizes a 1x plus 6, and the black half symbolizes a 1x plus 1. And you'll see that we've factorized the expression, and that's exactly what we got using sum and product. So this works when the coefficient is 1 as well. All right, let's try the whole thing on one square. So all the steps using the same grid. Remember, step 1, we fill in the top row, A, B, A, C. So A is 2, B is negative 9, and AC is 2 times 7 is 14. Now, we're looking for two numbers that multiply to make 14 and add to make negative 9. Multiply to 14, add to negative 9. Now that's a tough one because we've got to use a double negative trick. If you get stuck, you can draw a 14 over here and think about pairs of numbers that multiply to 14. Think about 1 and 14, 2 and 7, but then remember you also have the option of negative 1, negative 14, negative 2, negative 7. And this pair here is the one that adds to negative 9, so we'll use that. Negative 7, negative 2. All right. So that was step 2. Step 3 is find the highest common factor in this bottom left corner. Now, to do that, we consider the highest common factor of positive 2 up the top here and negative 2 down the bottom right. The highest common factor of those two is 2. Step 4, multiply everywhere. 2 times what gets you to neg 2? Well, that's minus 1. 2 times what gets you to 2? That's 1. 1 times what gets you to neg 7? Neg 7. Then, band-aid. The red half of that band-aid is 2x take 7. And then x minus 1. Now, if we want to check that's right, and it's a really good idea to be able to check it's right. Sorry, technical issues. Then we can expand out and hope it comes back to this. All right, so you can either use the grid method of expansion or FOIL. Both work. I'm going to use FOIL here. So 2x times x is 2x squared. 2x times negative 1 is negative 2x. Negative 7 times x is negative 7x. Then negative 7 times negative 1 is positive 7. We look for like terms. They're in the middle. Then we have 2x squared minus 9x plus 7. And that's exactly what we had above. So what we've done is factorize it successfully. All right, two more. And this just takes practice. I know they seem like lots of steps, but by the time you start going through them quickly and again and again and again, you'll be able to do these with your eyes closed. The hardest bit is finding the factors that add up to B. All right, first step, A, B, A, C. 10, 11, negative 60. Now, we're looking for things that multiply to negative 60. Whoa. Multiply to negative 60, but add to positive 11. So lots of things multiply to negative 60. So negative 6 and 10, negative 10 and 6. Neither of those add to 11. You can search on your calculator, and to do that, you'd simply type in negative 60 divided by some number. Let's say you divided it by 3. The answer would be negative 20. Then you'd know that 3 and negative 20 are also factors. You'd have to do a bit of searching, but eventually you'd find that, negative 4 and positive 15 multiply together to make 60. All right, so negative 4 and positive 15 go in here. They multiply to make -60, and they add to 11. Now, taking the highest common factor of the top left and bottom right, 10 and 15 is 5. Then, multiplying everywhere. 5 times 3 gets us to 15. 5 times 2 gets us to 10. 2 times -2 gets us to -4. Then, Band-Aid. Black half of the Band-Aid is 2x plus 3. Red half is 5x take 2. And note, the order we write those bracket pairs doesn't matter. We could have the 5x take 2 first. And no, they don't have to be color-coded. I'm just showing you where they've come from. All right. Last one. Now, normally you wouldn't be given a grid. In fact, it'd be extremely rare for you to be given a grid to do the working on. So I'd be expecting you to draw it up yourself. Doesn't have to be beautiful. Then A, B, A, C. Looking for what multiplies to 110, adds to 27. That's hard. Once again, grab your calculator, search for it. Turns out that 22 times 5 is 110, and 22 plus 5 is 27. Then highest common factor of 10 and 5 is 5. 5 times 1 is 5. 5 times 2 is 10. 2 times 11 is 22. And Band-Aid. Black half is 2x plus 1. Red half is 5x plus 11. Alright, sorry it's been a long video. This skill is hugely important. You need to be able to factorize quickly and efficiently. And the two quickest ways are sum and product if the number at the front is 1. If it's not 1, there are many ways to do it. This is, well, my favorite way. One thing I should point out is that not every quadratic that looks like this can be factorized. Sometimes it just won't be able to be done. However, in the textbook, all the ones you're likely to come across for year 9, you will be able to factorize. But just thought I should mention, this will not always work. Can you please complete those two in your OneNote in time for Monday? Thank you very much, and I'll see you on Monday.